quiet hum of the universe has always whispered secrets to those patient enough to listen. Since the dawn of human consciousness, we've been explorers, not just of land and sea, but of thought, mystery, and the nature of existence itself. Tonight, as you settle into sleep, allow yourself to drift into a gentle journey through time. Not a journey through war or conquest, but through the mind, through the unfolding of scientific thought, discovery by discovery, moment by moment. This is the story of our greatest revelations, told softly, slowly, designed to help you relax and fall asleep as you learn about the wonders of our world. Let's begin at the very beginning. Before science had a name, before mathematics had symbols, humans still looked to the skies. Ancient stargazers, from Mesopotamia to Egypt, from China to Mesoamerica, marked the movements of the stars and planets. They carved calendars into stone. They watched the patterns of seasons and shadows. This wasn't science yet, not quite, but it was the beginning of observation, of pattern, of wonder. Around 600 BCE, a man named Thales of Miletus proposed that everything in the universe was made not from myth or magic, but from a single element, water. It may not have been accurate, but it was revolutionary. It suggested that there were rules beneath the surface of the world, and that those rules could be found not in legend, but in nature itself. Not long after Thales, Pythagoras walked the shores of the Ionian Sea and pondered numbers. He saw music in mathematics and believed numbers had divine properties. His famous theorem would go on to become a foundation of geometry, but more importantly, he planted a seed. That abstract reasoning could describe the physical world. Centuries passed, and knowledge grew slowly, often lost and then found again. In the city of Alexandria, the great library held tens of thousands of scrolls, and scholars came from across the world to learn, debate, and dream. There, around 300 BCE, Euclid compiled his Elements, a collection of geometric knowledge so precise and enduring that it's still studied today. At the same time, Aristarchus of Samos dared to suggest that the Earth orbits the Sun, nearly 2,000 years before Copernicus would prove it. But as empires rose and fell, much of this ancient wisdom was buried beneath time. It would take the world a long time to remember. In the Islamic Golden Age, spanning the 8th to 14th centuries, science flourished in a different part of the world. In Baghdad, Cairo, and Cordoba, scholars translated ancient texts, preserved Greek and Roman thought, and added their own brilliance. Alhazen studied optics and the nature of vision. Avicenna wrote encyclopedias of medicine. Algebra was named and developed by Al-Khwarizmi. Astronomy, chemistry, biology, all evolved here in quiet rooms lit by oil lamps, scrolls unrolling on polished wooden tables, instruments aligned with the heavens. And then, the Renaissance. It began slowly, like a spark catching dry leaves, and then it spread. In 1543, Nicholas Copernicus published a book that said, quietly and without fanfare, that the Earth was not the center of the universe. The stars did not revolve around us. We revolved around the sun. It was a quiet revolution, a model that rearranged the cosmos in the human mind. A few decades later, Galileo Galilei raised his homemade telescope to the sky and saw moons orbiting Jupiter. He saw phases of Venus and craters on the moon. He confirmed Copernicus, and he paid the price for it. But the age of modern science had begun. Empiricism, the practice of testing, observing, and questioning, took root. And then, Newton. Born in 1643, Isaac Newton changed the world not with a sword, but with a quill. By the time he was in his 20s, he had discovered the laws of motion, invented calculus, and described gravity, not as a force of magic or divine will, but as a natural law that governed the entire universe. He watched an apple fall and saw the same force that pulled the moon in its orbit. He published his Principia Mathematica in 1687, and with it, science became a language. A precise mathematical language that could describe everything from falling apples to planetary orbits. The Enlightenment followed, an era of reason, where observation replaced superstition and doubt became a tool of progress. Chemistry separated from alchemy. Biology emerged from the shadows of folklore. Scientists like Robert Boyle, Antoine Lavoisier, and Carl Linnaeus laid the groundwork for entire disciplines. Lavoisier discovered that matter is neither created nor destroyed. The law of conservation of mass. Boyle studied gases and their behavior under pressure. Linnaeus created a system to classify all living things. The world was becoming ordered, measured, understood, and yet mysteries still remained, deep ones. By the early 1800s, the Earth had been mapped, the skies charted, and yet life itself remained a mystery. How did one species become another? Why did creatures change over time? Why did fossils show forms that no longer lived? In 1831, a young man named Charles Darwin set sail on the HMS Beagle. For 5 years, he explored the coasts of South America, the jungles of Brazil, and the volcanic islands of the Galapagos. He noticed differences in finches, in tortoises, in plants, variations that seemed to match their environments. Quietly, he formed a theory. He waited. He tested. And in 1859, he published On the Origin of Species. The idea was simple, but powerful. Those organisms best adapted to their environment survive and reproduce. Those less adapted do not. Over time, species change. Nature selects. Evolution happens. It was controversial. It was misunderstood. But it reshaped biology forever. Around the same time, another revolution was stirring, this one invisible to the eye. In labs and workshops across Europe, electricity danced in glass tubes. Magnetism moved needles, light bent and split into rainbows. In 1864, James Clerk Maxwell unified electricity and magnetism into a single theory, a set of 4 elegant equations that predicted light itself. For the first time, physicists realized light is an electromagnetic wave. The universe was not just governed by laws, it was made of them. Still, there was more to discover. In a Swiss patent office in the early 1900s, a young man named Albert Einstein reimagined space and time. He proposed that time was not absolute, but relative. That light always moved at the same speed, no matter the observer. From this came special relativity, and eventually the famous equation, E equals mc squared. Energy and matter were the same thing in different forms. Einstein later expanded his theory into general relativity, which described gravity not as a force, but as the warping of space and time. Suddenly, the cosmos had curves. The universe could bend. And just when we thought the universe was orderly, quantum mechanics arrived. Strange, uncertain, and deeply unsettling. Particles were not just particles. They were also waves. They could be in many states at once, a superposition, until measured. Heisenberg's uncertainty principle, Schrödinger's cat, the dual nature of light. At the atomic scale, the universe played by rules that seemed to defy logic. But they worked, and they predicted with astonishing accuracy. The 20th century saw more discoveries than perhaps all previous centuries combined. We split the atom. We mapped the genome. We discovered penicillin, developed vaccines, landed on the moon, and peered billions of light years into space. But tonight, we rest. You don't need to understand all the equations or remember all the names. Just know this. The story of science is the story of us, of curiosity, of wondering why the sky is blue, or how birds fly, or what lies beneath the ocean. It is a story of questions, and slowly, softly, of answers. And we are still discovering. As the 20th century unfolded, science accelerated like never before. The great wheel of discovery spun faster, and each turn revealed something new, something stranger, something more beautiful, and sometimes something more terrifying. At the dawn of the century, a few curious scientists were investigating something invisible, something that passed through flesh, through bone, even through walls. They called them rays. In 1895, Wilhelm Röntgen discovered X-rays, invisible waves that could image the bones inside the human body. Just 1 year later, Henri Becquerel stumbled upon radioactivity. And then came Marie Curie. With quiet determination, Marie and her husband Pierre isolated radioactive elements like polonium and radium. She became the first woman to win a Nobel Prize, and the only person to win Nobel Prizes in 2 different sciences, physics and chemistry. Her work helped create modern medicine, from cancer treatments to medical imaging, but it also laid the groundwork for something far more dangerous. In the early 20th century, scientists uncovered the structure of the atom. Protons, neutrons, electrons. They discovered that energy wasn't continuous, but came in discrete packets, quanta. They called it quantum physics. And it would lead to technologies and ideas no one had imagined. In 1938, scientists in Germany discovered that by bombarding uranium with neutrons, the atom could split, releasing enormous energy. Nuclear fission had been discovered, and with it, the age of the atom had begun. In laboratories hidden in deserts and bunkers, scientists from across the world gathered in secret. The Manhattan Project, a race to build a bomb before others could. The result was something the world had never seen. A single device that could destroy an entire city. In 1945, that power was unleashed over Hiroshima and Nagasaki. The Second World War ended, but humanity had crossed a threshold. We had unlocked the forces at the heart of a matter, and we now carried the burden of that knowledge. Yet even as we explored destruction, we also explored the stars. The Cold War may have divided nations, but it also inspired exploration. The United States and the Soviet Union began a space race. Satellites were launched. Animals orbited the Earth. And then, in 1961, Yuri Gagarin became the first human to journey into space. 8 years later, Neil Armstrong stepped onto the surface of the moon and said words that echoed around the planet. That's one small step for man, one giant leap for mankind. Imagine, a species that once crouched in caves, now walking on another world. But perhaps the most profound discoveries of the 20th century weren't about where we could go, but what we were made of. In 1953, James Watson and Francis Crick, building on the work of Rosalind Franklin, revealed the double helix structure of DNA. With this, we had unlocked the code of life, the instructions written in every cell, in every organism. Genetics would never be the same. DNA led to the Human Genome Project, a global collaboration to map every gene in the human body. And today, we can edit that code. With CRISPR, a revolutionary gene editing tool, we can now correct genetic diseases, enhance crops, and possibly reshape evolution itself. The power is breathtaking and deeply humbling. But science is not only about the big and the powerful. Sometimes the smallest insights reveal the greatest truths. In the 1960s, two scientists, Arno Penzias and Robert Wilson, were adjusting a radio antenna when they heard a faint hiss, a background noise they couldn't eliminate. It turned out to be the cosmic microwave background radiation, the afterglow of the Big Bang, the birth of the universe itself still whispering across the cosmos. From that, cosmology took shape. Scientists pieced together the story of everything, that the universe began around 13.8 billion years ago in a hot, dense state, and has been expanding ever since. Galaxies, stars, planets, all born from that initial explosion of energy. And yet, as we looked outward, we also looked inward. Our understanding of the brain, the mysterious organ behind our thoughts, dreams, and fears, advanced in leaps. Neurons fired signals. Electrical pulses formed memories. We discovered that the brain was plastic, able to change and rewire itself. Psychology merged with biology, and we began to understand the mind as both a product of biology and experience. But still, mysteries remain. What is consciousness? What does it mean to be aware, to feel, to know that we are here? Some questions are still beyond the reach of equations. Others are simply waiting. And as we sleep tonight, laboratories around the world hum with quiet energy. Experiments run. Telescopes scan the stars. Computers simulate galaxies, weather, molecules, and time itself. In Switzerland, the Large Hadron Collider sends particles hurtling at near-light speed, smashing them together to glimpse the fundamental forces of nature. In 2012, this machine helped confirm the existence of the Higgs boson, the God particle, a field that gives other particles their mass, a missing puzzle piece found after decades of searching. In observatories deep underground, scientists search for dark matter, an invisible form of mass that seems to make up most of the universe. We cannot see it, but its gravity shapes galaxies. What is it? We don't yet know. And then there's dark energy, a force that causes the universe to expand faster and faster. It too remains a mystery. Sometimes, the more we learn, the more we realize how much we don't know. And that is the beauty of it. Because science is not a list of facts. It is not a dry textbook. It is a way of seeing, a way of asking, a way of dreaming. It is the child who asks why the sky is blue. It is the sailor who navigates by the stars. It is the doctor who studies cells to heal the sick. It is the mathematician who finds elegance in numbers, and the astronomer who sees wonder in galaxies. It is you listening now, curious, calm, drifting. As you sleep, the universe continues. It expands, it pulses, it glows, and we, small as we are, continue to reach. Not in water, not in air, but in space. The stars stretch out infinitely around you. Below, the earth glows blue and green, cradled in night. You are weightless, timeless, calm. This is where science has brought us, from questions whispered in ancient temples to spacecraft orbiting planets, from counting seasons to measuring time with lasers, from staring at firelight to creating artificial suns in reactors of fusion. And yet, some of the most impactful scientific discoveries have nothing to do with space or atoms, but with life itself. Let us drift now into biology. Before the 19th century, the human body was still largely a mystery. Illness was often misunderstood. The causes of disease were guessed at, blamed on spirits or imbalances. But as the microscope evolved, so too did our vision. In the 1670s, Antony van Leeuwenhoek peered through his handmade lenses and saw a world no human had ever seen. Tiny creatures swimming in a drop of water, bacteria. He called them animalcules. Though he didn't fully understand what they were, he had opened a doorway into the microbial world. Later, in the 19th century, Louis Pasteur and Robert Koch would connect these microbes to disease. The germ theory was born. Diseases like cholera, anthrax, and tuberculosis were no longer mysterious afflictions. They were caused by microscopic invaders, and with this knowledge came prevention. Pasteur developed the first vaccines for rabies and anthrax. He showed how heating milk, pasteurization, could kill harmful bacteria. Koch developed techniques to isolate and identify bacteria, laying the groundwork for modern microbiology. This understanding changed everything. Hospitals became cleaner, surgery became safer, public health improved, the average human lifespan began to rise. Then came penicillin. In 1928, Alexander Fleming returned from vacation to find a petri dish with mold growing on it, and a clear ring where bacteria had died. The mold was Penicillium notatum, and it would become the world's first true antibiotic. Penicillin would save millions of lives during World War II and usher in the age of antibiotics. We had learned how to fight the unseen, but even deeper than bacteria lay the blueprint of life. As we explored DNA, we began to understand genes, not as abstract concepts, but as real physical strands of code. We learned that each cell carries instructions, billions of chemical letters, written in a code of 4 bases, A, T, G, and C, arranged in just the right way. They build you, your hair color, your height, your voice, your immune system, your potential, and more than that, they connect you to everything that breathes. You share DNA with chimpanzees, with mice, with trees, with yeast. The story of life, it turns out, is one long sentence, written, rewritten, and edited over billions of years. Evolution is not just a theory, it is a pattern, one that can be read, traced, and understood at the genetic level. And with that knowledge came new power. We mapped the entire human genome, over 3 billion letters long. We learned to edit genes with precision. With CRISPR, we can snip out defective genes and replace them. We can cure inherited diseases in embryos. We can modify plants to resist drought and bacteria to clean up oil spills. We are writing with life. Of course, with such power comes responsibility. The ethics of genetic editing are deep and still evolving. Should we alter the human genome? Should we choose the traits of future generations? Where does medicine end and engineering begin? Science always walks hand in hand with questions, and while biology and medicine reached inward, another revolution unfolded outward, in information. In the mid-20th century, engineers built the first digital computers, room-sized machines that could perform simple calculations. They were slow, delicate, and massive. But like all technologies, they evolved. By the 1970s, computers fit on desks. By the 1990s, they fit in backpacks. Today, they fit in your pocket. And they have changed everything. Information now moves faster than light, carried on fiber optics, bounced off satellites, processed by algorithms. With the internet, humanity built a neural network of its own. Ideas, knowledge, emotions, shared instantly, globally. Computers help diagnose disease, they simulate weather, they play chess, compose music, translate languages, and now even write and draw. And just as Newton once gave us laws of motion, today we study laws of computation, of data, of artificial intelligence. AI, a field that once lived in science fiction, is now all around us, in phones, in hospitals, in cars, in factories, in article. We are training machines to learn, to adapt, to assist, and perhaps one day to think. Will machines ever be conscious? Will they dream as we do? These questions remain open, waiting for time to answer. But technology also connects us to the past. With machines, we've scanned ancient ruins, reconstructed lost languages, visualized extinct species. We've 3D printed organs, simulated brain activity, and perhaps most profoundly, we've recreated the sound of a heartbeat from a mummy, long gone. Through science, the past speaks, and the future listens. Let us pause now. Breathe. You are lying in a bed, but your mind has travelled far, across centuries, across galaxies, across scales from the tiniest particles to the vastness of space. You've met philosophers, physicists, doctors, and dreamers. You've watched stars explode and atoms split. You've seen what lies beneath skin and beyond clouds. And through it all, you've felt one constant: curiosity. That gentle urge to know, to understand, to connect. It's that same urge that once made a child reach for a firefly, that made an old man wonder why apples fall, that made a young woman follow a beam of X-rays to a Nobel Prize. Science is not cold or mechanical. It is human. It is deeply, beautifully human. It is a lullaby of logic, a poem written in equations, a soft voice whispering, "There is more to know." And tonight, as your eyes grow heavy and your breath deepens, know that you are a part of this story, the great story of discovery. Sleep gently now. The universe will be here when you wake. Let your thoughts drift once more. You are in a quiet room filled with books, ancient scrolls, glass beakers, glowing screens, all coexisting in harmony. This is the imagination's library, where every discovery, every breakthrough gently whispers its story. Let's walk deeper into that library, into some of the discoveries that didn't just change what we know, but changed how we live. Take, for instance, the understanding of electricity. Today, you flip a switch and light fills the room. But for millennia, lightning was just a mystery, a terrifying and beautiful phenomenon that lit up the sky and struck without warning. It wasn't until the 18th century that Benjamin Franklin flew his famous kite into a storm and proved that lightning was a form of electricity. It was a dangerous experiment, and it only scratched the surface. In the 1800s, scientists like Alessandro Volta, Michael Faraday, and James Clerk Maxwell transformed our understanding of electrical forces. Volta invented the battery, a device that could store and release energy. Faraday showed how a moving magnet could generate current, the basis for electric motors and generators. Maxwell's equations, beautiful and precise, unified electricity, magnetism, and light into one elegant theory. Electricity moved from the clouds into our homes, our cities, our lives. From it came the electric light, the telegraph, the telephone, the radio, the television. Voices and music travelled across wires, then across air, then across space. Imagine for a moment how magical it must have felt to hear someone's voice from miles away, in real time, with no visible connection. That magic was radio, born from the work of Hertz, Marconi, and Tesla. Soon, cities were glowing at night. Trains ran on current. Machines came to life at the press of a button. And electricity didn't just light up the world. It powered another kind of revolution, the industrial one. Steam had started it in the 18th century when James Watt refined the steam engine. Factories grew, coal burned, machines hummed, The world became faster, louder, more connected. But electricity changed everything again. It allowed for cleaner energy, more efficient production, longer work hours, and new inventions. Refrigerators, elevators, record players, computers. The Industrial Revolution was not just about machines. It was about control over energy, about learning to channel fire, water, wind, and atoms. And with that power came challenges: pollution, inequality, climate change. Science gave us power. Now it asked us to use it wisely. And so began the next great movement in discovery, environmental science. In the 20th century, as cities grew and industries expanded, the earth began to change. Forests vanished, rivers darkened, air thickened with smog, and yet most people didn't see it until science showed them. In 1962, a biologist named Rachel Carson published Silent Spring, a book that revealed how pesticides, especially DDT, were poisoning birds, animals, and humans. It shocked the public. It led to new laws. It sparked the environmental movement. We began to measure carbon in the atmosphere, track melting ice, map dying coral reefs. We launched satellites to watch the planet breathe, to monitor forests, oceans, storms, and heat. And what we saw was clear. Earth is changing, and we are the cause. Climate science became one of the most important and urgent fields. Scientists studied greenhouse gases, global warming, rising sea levels, species extinction. They built models not to scare, but to warn, to prepare, to give us time. Because science is not prophecy, it is possibility. It says, if this continues, then that will follow. It gives us the choice. And through science, we also found solutions: renewable energy, electric vehicles, green architecture, vertical farms, clean water technologies, innovations that protect both people and planet. Even now, in quiet labs, scientists are designing materials that clean the air, machines that pull carbon from the sky, systems that mimic nature's balance. The future can be beautiful, but it must be chosen. And while we ponder the future of our world, we also reach farther to other worlds. Astronomy, the oldest science, has never stopped evolving. From ancient stargazers to space telescopes, our view of the cosmos has expanded beyond imagination. In 1995, the first exoplanet, a planet outside our solar system, was discovered. Since then, we've found thousands more, some hot, some icy, some rocky, like Earth, some with strange atmospheres of methane, water, or hydrogen, some orbiting twin suns. We now believe there are more planets than stars in the universe. And if there are billions of stars and billions of planets, then how many carry life? We don't yet know, but we are listening. Radio telescopes sweep the sky, listening for signals. Rovers crawl across Martian soil, drilling, scanning, searching. Probes pass by Saturn's moons and Jupiter's storms. And the James Webb Space Telescope peers deep into time, catching light that began its journey billions of years ago. It sees galaxies forming, stars dying, black holes feeding. It sees what no eye has seen before, and through it we learn not just about space, but about time. Light, after all, is memory. When you look at a star, you see it not as it is, but as it was. You are witnessing its past, a message carried across light years, delivered softly to your eyes. In this way, astronomy is both science and poetry. It tells us how everything began, and hints at how it might end. Some scientists believe the universe will continue expanding forever, growing colder and darker until even atoms decay. Others imagine a cosmic rebirth, a new Big Bang after the last whisper of light. We do not know, we may never know, but we continue to ask. And in that asking is something sacred. A final field of discovery awaits us now. The study of the human mind. For all our achievements, all our rockets and vaccines and theories, the mind remains our most mysterious frontier. How do neurons give rise to thoughts? How do chemicals become emotions? What is the self? Neuroscience, psychology, psychiatry, they probe these questions. Brain scans reveal activity as we speak. Remember, love, dream. We map the brain's regions. We trace signals. We identify patterns. But still, no scientist can yet explain exactly what consciousness is. We know it's tied to the brain, but how and why? Why do we experience the world as selves, as I? Why do we dream? Why do we imagine? These are mysteries that remain. Delicate, elusive, sacred. And perhaps that is fitting, because for all its logic and evidence, science does not kill wonder. It feeds it. The more we know, the more we wonder. The deeper we dig, the more beauty we uncover. Not magic in the supernatural sense, but in the natural. In the astonishing elegance of how things are. You are made of atoms forged in stars. Your heartbeat follows rhythms shaped by physics. Your lungs fill with molecules that once flowed through trees, oceans, and dinosaurs. You are a walking library of biology, chemistry, astronomy, evolution, and time. And yet, you are also a mystery. You love. You dream. You wonder. That perhaps is the greatest discovery of all, that the universe, vast and ancient, has made something that can ask about itself. So as you drift deeper into rest, know this. You are not apart from the story of science. You are the story of science. A star's light slowed by time, woven into thought. A spark of curiosity, born in the dark, still reaching. Sleep now, softly. Tomorrow holds new questions. The rhythm of sleep gently settles over your body now, like waves washing upon a quiet shore. And even as you rest, the world of discovery continues turning. Let's wander together now into lesser known, but no less important, scientific breakthroughs. Stories that didn't always make headlines, but quietly shaped the course of human history. Let's begin in the soil, with agriculture. 10,000 years ago, human societies shifted from nomadic hunting and gathering to planting and harvesting. This was not simply a lifestyle change, it was a scientific revolution. Early farmers learned by observation when to plant, how deep to dig, which seeds grew best in which soil. Over generations, they selectively bred plants, stronger wheat, sweeter fruits, hardier vegetables. Though they didn't have a word for it, they were practicing genetics. By domesticating plants and animals, humans learned to manipulate biological systems. The discovery of irrigation, the careful control of water, allowed civilizations to rise in deserts and plains. And with agriculture came math, calendars to track seasons, measurements to divide land, and early forms of engineering. Fast forward to the 20th century, and agriculture entered another scientific phase, the Green Revolution. In the 1940s and beyond, scientists like Norman Borlaug developed high-yield, disease-resistant crops. Fertilizers, pesticides, and modern farming techniques multiplied food production. Famines were averted. Billions were fed. Today, scientists use genetics and AI to monitor soil health, predict yields, and engineer crops to survive drought and heat. Hydroponic farms grow food without soil. Vertical farms rise in skyscrapers. Agriculture, once tied to seasons and sunlight, is becoming a precision science. Now, let's shift from food to flight. For centuries, Humans watched birds and dreamed. Leonardo da Vinci sketched flying machines in the 15th century, but it wasn't until December 17th, 1903, that the dream took wing. In a quiet field in Kitty Hawk, North Carolina, the Wright brothers launched a powered, controlled aircraft. It stayed aloft for just 12 seconds, but it changed the world. Aviation evolved rapidly. Within decades, planes crossed oceans. Then they broke the sound barrier. Then they reached the edge of space. Flight made the world smaller. It connected people, cultures, and ideas. But flight also deepened our understanding of physics, of lift, drag, thrust, and aerodynamics. It pushed material science to create lighter, stronger components. It demanded new mathematics, new fuels, new systems of navigation. And now, aircraft are not just in the sky, they're on Mars. The Ingenuity helicopter, sent alongside NASA's Perseverance rover, became the first controlled aircraft to fly on another planet in 2021. Its blades spun in the thin Martian air, lifting gently from red soil, a century after the Wright brothers. From wood and cloth to titanium and solar panels, the story of flight is a testament to human imagination and persistence. Now let us look inward again, not into the body, but into the invisible. The science of materials. Think of glass. It seems ordinary, clear, smooth, fragile. But glass is one of the strangest substances we use. It's not a true solid, nor a liquid. It's something in between, an amorphous solid. Its atoms are disordered, like a liquid, but they don't flow. Humans first created glass around 4,000 years ago. Over time, it was refined, from beads to windows, from lenses to fiber optics. Today, glass carries data at the speed of light beneath oceans. It magnifies cells in microscopes and galaxies in telescopes. Now think of plastic. Once, everything we made came from natural materials: wood, stone, metal, bone. But in the 20th century, we learned to shape molecules, to build chains of carbon and hydrogen into polymers. Plastic could be soft or rigid, clear or opaque, flexible or strong. It revolutionized packaging, medicine, electronics, and more. But it also introduced new challenges: waste, pollution, microplastics. Now scientists are creating biodegradable plastics and enzymes that can break down existing waste. Materials science seeks not just function, but sustainability. And in labs today, scientists are building materials that can heal themselves, conduct electricity, change color, or resist extreme temperatures. Imagine a phone screen that repairs its own cracks, a building that flexes during earthquakes, clothing that responds to your body's temperature. These are not dreams, they are prototypes. Now let's take a gentle turn toward the science of time. Humans once told time by the sun and stars, then by sundials, then by mechanical clocks, gears and springs. But today, the most accurate clocks in the world are atomic. An atomic clock measures time by counting the vibrations of atoms, usually cesium. These vibrations are so regular that atomic clocks only lose about 1 second every 100 million years. Why is this important? Because our entire modern world depends on timing. GPS satellites must account for both special and general relativity, Einstein's theories, because time moves differently depending on speed and gravity. Without precise timing, your phone wouldn't know where you are. Banks couldn't timestamp transactions. The internet would break. Time is not absolute. It bends, it stretches, it slows. And science is the only reason we understand this and can use it. Let's pause for a breath here. Close your eyes if they're not already closed. You've heard stories of atoms and stars, of glass and crops, of wings and clocks. These aren't just facts, they are quiet symphonies of knowledge, composed over centuries by countless minds no different than yours. The desire to understand, to see the world not just as it appears but as it is, lives in all of us. And even the simplest discoveries can lead to the greatest changes. The concept of zero, first developed in ancient India, unlocked higher mathematics. The discovery of penicillin from a forgotten petri dish launched the antibiotic era. The observation of gravity, light, and pressure became rockets, lasers, and airplanes. All of it began with curiosity, and curiosity never sleeps. So as you lay there now, wrapped in warmth and quiet, know that science is still unfolding, in labs, in forests, in mines. The sun's light, 8 minutes old, still pours over the earth. Tides still follow the moon's pull. Bacteria still divide. Galaxies still spin. The world is not static. It is alive with patterns, and we are beginning to read them. The air is still. Your body is still. But the world is always moving. Atoms vibrate, stars collapse, thoughts ripple across neurons like waves across a lake, and somewhere quietly, another discovery is being made. As we continue our calm journey through the greatest scientific breakthroughs, let's shift our focus now to something at once ancient and ever new: medicine. From the earliest times, humans have tried to understand illness and healing. In ancient Egypt, papyrus scrolls listed remedies of herbs, honey, and animal parts. In Greece, Hippocrates proposed that diseases had natural causes, not spiritual ones. He emphasized observation, the foundation of modern clinical practice. He said, "First, do no harm." In India, Ayurveda, the science of life, taught balance through diet, herbs, and lifestyle. In China, traditional Chinese medicine focused on energy, flow, and harmony between body and nature. Across the world, ancient peoples built systems of healing based on experience, tradition, and intuition. But it was not until the rise of modern science that medicine began to transform into what we now recognize. Let's begin with the discovery of circulation. For centuries, people believed blood was made in the liver and consumed by the body like food. But in 1628, English physician William Harvey published his theory that the heart was a pump, that blood circulated in a closed system, pushed through arteries and returned through veins. It was simple, elegant, revolutionary. Next came anesthesia. Before the 19th century, surgery was brutal. Patients were held down, screaming, as doctors worked quickly. But then, gases like ether and chloroform were discovered to dull sensation. Surgery became calmer, safer. Pain, once accepted as inevitable, could be managed. Then came antisepsis. In the 1860s, Joseph Lister applied Louis Pasteur's germ theory to surgery. He used carbolic acid to sterilize instruments and clean wounds. Mortality rates dropped. Cleanliness saved lives. Vaccines had already begun their journey. In 1796, Edward Jenner noticed that milkmaids who caught cowpox never caught smallpox, a deadly disease. He tested this idea and discovered the first vaccine. Over the next 2 centuries, vaccines would go on to prevent, and in some cases eliminate, diseases like polio, measles, diphtheria, and smallpox itself. And then, penicillin. As we mentioned earlier, Alexander Fleming's accidental discovery of the world's first antibiotic revolutionized medicine. But penicillin was just the beginning. Countless antibiotics, antivirals, antifungals, and immunotherapies followed. Diseases that once wiped out millions could now be treated with a pill, an injection, a plan. And still, medicine advances. In the 20th and 21st centuries, Imaging technology gave us new eyes. X-rays showed bones. CT scans revealed slices of the body in 3D. MRIs let us peer into soft tissue, brain activity, even thoughts in motion. Ultrasound let us see the unborn. PET scans revealed tumours long before symptoms arose. The body was no longer a mystery. It became a landscape of structures and signals. Now we can operate through tiny incisions using robotic arms. We can 3D print prosthetics, bones, and even human organs. We can replace hearts. We can repair spines. We can restore sight. With stem cells, we can regrow tissues. With gene therapy, we can correct inherited diseases at the source. And through all of this, science doesn't just fight death. It enhances life. Public health, nutrition, sanitation, vaccines, and modern medicine have nearly doubled the human lifespan in just 200 years. What was once old age is now middle age. Diseases that once devastated populations are now manageable or gone. But the greatest challenges remain: cancer, Alzheimer's, autoimmune diseases, mental illness, and now, pandemics. The COVID-19 pandemic reminded the world that science is not a luxury, it is survival. Vaccines were developed in record time thanks to decades of research in virology, mRNA technology, and global collaboration. Genomic sequencing tracked the virus. AI helped design molecules. Data science mapped its spread. It was a tragedy, but also a triumph of modern science. And perhaps no field embodies this spirit more than neuroscience. The study of the brain, that soft, silent organ behind our eyes, is unlocking the secrets of memory, emotion, and identity. We now understand that the brain is not static. It rewires itself. It grows new neurons. It responds to thought, to behavior, to environment. We can read electrical signals in real time. We can map entire neural networks. We can treat depression with magnets and machines. We can even connect brains to computers, helping paralyzed people move robotic limbs or type with their thoughts. And still, the mystery remains. What is a thought? What is a memory? Why do we dream? Why do we feel? Science can describe the mechanics, but consciousness remains a riddle. A delicate flame burning quietly in the dark, lighting the universe from within. Now let's leave the body behind and return to the stars. In recent years, astrophysics has made stunning strides. Gravitational waves, predicted by Einstein in 1916, were first detected in 2015. These ripples in space-time, caused by colliding black holes, were measured by the LIGO Observatory. It was like hearing the universe breathe for the first time. Black holes, once theoretical, have now been seen, photographed as glowing rings around dark centers, warping light itself. We've measured the cosmic microwave background in exquisite detail, the afterglow of the Big Bang frozen in time. We've seen stars born in clouds of gas. We've watched them die in supernovae. We've detected fast radio bursts from deep space, signals from something still unknown. And always we ask, are we alone? The answer is still out there, waiting. But science is patient. Science doesn't rush. It watches, it waits, it wonders. Like you now, quiet, resting, still. Perhaps one day, long from now, a distant civilization will detect the faint signals we sent. Golden records aboard Voyager, carrying sounds of whales, greetings in 55 languages, music from Earth. And maybe, far in the future, long after you and I are gone, they'll find our mathematics, our discoveries, our maps of the stars. And in that moment, two distant minds, two sparks of curiosity, will connect across time and space, Because science is the language of the universe. And you, dear listener, are fluent, simply by being curious. Rest easy now. The journey continues. Let the night deepen around you. With every breath, the weight of the day slips away. And what remains is peace, and a quiet curiosity still glowing softly in the background. We've explored the vast and the microscopic, the body and the cosmos. But there's another realm of scientific discovery, one that affects everything from your morning routine to global civilization. It's the science of systems, of how things work together, of patterns, complexity, and the unexpected. Let's start with something simple. Boiling water. You've likely done it countless times. But hidden within that rising steam is a concept called phase transition, when matter changes from one state to another. Water becomes vapor, ice becomes water, and with it, the molecules rearrange, energy is exchanged, and a new order emerges. This principle, from the tiny to the massive, is foundational in physics, chemistry, and even biology. But systems science goes further. It looks not just at parts, but at how parts interact, at how feedback loops form, at how order can emerge from chaos. Take the weather. A thunderstorm may seem like a random burst of wind and rain, but it's a system, a dance of heat, pressure, moisture, and terrain. Tiny changes in one part of the atmosphere can ripple outward, creating entirely different outcomes. This sensitivity is known as the butterfly effect, and it's part of chaos theory, a field of science that studies complex dynamic systems that are sensitive to initial conditions. A butterfly flaps its wings in Brazil, and weeks later, it rains in Tokyo. That's the idea. Now imagine applying this to ecology. An ecosystem isn't just a forest, it's a network of relationships. Trees, insects, fungi, soil, water, animals, all in balance. Remove one species and the system can collapse or evolve in unexpected ways. In Yellowstone, the reintroduction of wolves, a predator, not only controlled deer populations, but changed the flow of rivers. How? The deer, now avoiding open valleys, allowed vegetation to regrow. This stabilized soil, which slowed erosion, which changed water patterns. One animal reshaped an entire landscape. This is the beauty of systems. Everything is connected. And in the modern world, systems science helps us understand traffic, economics, climate, disease outbreaks, social networks, and even the spread of ideas. It's how we model pandemics, how we predict stock market trends, how we design cities, simulate natural disasters, and manage global supply chains. These discoveries don't always have a single name or face. They come from collaboration, from scientists across disciplines, sharing tools, language, and vision. And in the center of many of these systems is data. Big data, vast collections of information, gathered from sensors, satellites, social media, experiments, and machines. Data science helps us see patterns invisible to the naked eye. With machine learning, a branch of artificial intelligence, we train algorithms to find insights in oceans of data. They help doctors detect cancer early, help meteorologists track hurricanes, help farmers predict yields, help researchers model climate futures. The discoveries of the future may not be eureka moments in lonely labs, but patterns, softly emerging from billions of data points, quietly revealing truths. Now let's shift once again to something closer to the soul, to the science of beauty. Yes, beauty. We often think of science as cold, analytical, precise, but some of the greatest scientific minds have spoken of awe, elegance, and wonder. Albert Einstein once said, "The most beautiful experience we can have is the mysterious." Physicist Paul Dirac spoke of beauty in equations, how the most powerful theories often have a kind of symmetry, a harmony. Mathematicians see beauty in the Fibonacci sequence, in prime numbers, in fractals, patterns that repeat at every scale, from ferns to coastlines to galaxies. Biologists see beauty in the spiral of a seashell, in the iridescence of a butterfly wing, in the perfect fit between a flower and its pollinator. Astronomers see it in the rings of Saturn, in the way galaxies swirl, in the vast structures of the cosmos, filaments of matter stretching like webbing across billions of light years. Even chemists speak of elegance, the satisfying way certain molecules form, bond, react. Beauty, in science, is often a clue. When something feels beautiful, when it feels right, it often turns out to be true. Not always, but often enough to matter. And this speaks to something deeper, that science is not separate from emotion. It doesn't extinguish wonder, it nurtures it. The more we understand, the more awe we feel. Now let's drift for a moment into mathematics, the language behind the curtain. Math is not just about numbers, it's about structure, logic, relationship, infinity, probability, patterns. When Pythagoras discovered that musical notes could be described mathematically, that certain ratios produced harmony, it changed not just music, but math itself. When Newton created calculus, he wasn't just solving equations, he was creating a new way to describe motion, change, growth, from falling apples to orbiting planets. When Euclid defined geometry, he built a system that would guide architecture, astronomy, and art for thousands of years. Mathematics underpins everything: physics, engineering, economics, genetics, artificial intelligence. It helps us describe the curvature of space, the flow of fluids, the behavior of particles, and the spiral of hurricanes. It lets us simulate the human heart. It lets us land a rover on Mars. And mathematics is infinite. There are theorems still unsolved, problems that resist even the smartest minds, prime numbers with no pattern, dimensions beyond our perception. It is a universe within a universe, a frontier without end. Now, breathe. Feel your body supported, your breath slow, your mind calm. You are surrounded by science, not in the abstract, but in the most intimate way. The warmth of your blanket, thermodynamics, the steady beat of your heart, biology, the silence of the room, acoustics, the glowing screen that brought these words to you, electromagnetism, computing, and quantum mechanics, and within you, a mind evolved to wonder. You are not just learning science, you are made of science. Atoms forged in stars, molecules shaped by evolution, thoughts sparked by electricity, memory, and experience. You are a symphony of systems, and yet, still, more than the sum of your parts. Sleep now, held by knowledge. You are safe. You are curious. And your journey is just beginning. You've travelled far, across centuries of questions and galaxies of thought. You've walked beside thinkers and dreamers, floated through atoms and stars, and listened to the quiet pulse of discovery that hums beneath everything. From the spark of fire to the edge of the observable universe, from the shape of your DNA to the whisper of a gravitational wave, every moment, every breath is touched by science. And now, it's time to rest. Let the weight of the world drift away. Let your body become light. Let your thoughts dissolve into stillness. The questions will still be there tomorrow, but for now, all you need to do is sleep.